Hello, everyone. Bye, Trey. Trey was just leaving. Hello, everyone. I wanted to do another problem with our calorimeter and calculating delta H in kilojoules per mole. So a question like this is pretty much going to be the extent of your FRQ questions. The lab that you did was utilizing this process, but then thinking about several different compounds. And in this one, we're only thinking about what's happening in one coffee cup calorimeter and just one compound in it. So, for example, for number one, I have when a 6.50 gram sample of solid NaOH, so solid sodium hydroxide, dissolves in 100 grams of water in a coffee cup calorimeter, the temperature will rise 21.6 degrees Celsius to 37.8 degrees Celsius. So right off the bat, I know that since this temperature is rising, the water temperature is rising, would this be an exothermic reaction or would this be an endothermic reaction? It would be, if my temperature is rising from 21.6 degrees Celsius to 37.8 degrees Celsius, it would be an exothermic reaction because I would be releasing energy into that water. So I want to calculate the delta H in kilojoules per mole for this solution process when sodium hydroxide is dissolving in water. And let's assume that the specific heat of water is 4.18 joules per gram degrees Celsius. So I'm going to try to shrink this, so hopefully you can maybe like pause this and get what you need from this, but I need to shrink it so we have enough space to work with. I think you can still read that. Okay. So I need to find delta H in kilojoules. So first we know that delta H is equal to Q. So I know also Q is equal to MCAP. So I'm trying to find Q because that would give me my energy, that would give me my joules. So I know that the total mass, I dissolve 6.50 grams of the solid NaOH, but I also have 100 grams of water. What if I would have given that to you, what if I would have said you had 100 mils of water? How many grams of water would you have?
100.
We'd have 100 because the density of water is 1 gram per 1 milliliter there. So my milliliters would cancel. I would have 100 grams there. Okay. So let's go back. So the total mass, which is what we're trying to solve for, total mass would be 6.50 of NaOH and 100 grams of water. So that would be 106.5. So Q equals 106.5 grams for the mass. They told us that we should assume the specific heat of water is 4.18 joules per gram degree Celsius. So I'm going to do times 4.18 joules per gram degrees Celsius. And then my change in temperature was 37.8, and that would be my final, and the initial was 21.6. So I always want to do final minus initial. So it should always be the last one minus the first one. So 37.8 minus 21.6, that would give us 16.2. So 16.2 degrees Celsius. Okay, so then I have everything that I need to solve for Q. So let's plug that in, and that would give us that would give us 7,212, but technically what, 3 sig figs, so should be 7,210 joules. But I need that to be in kilojoules. So if I have joules but I need kilojoules, I need to divide this by 1,000. So if I divide this by 1,000, that would give me my kilojoules. So that would give me 7.21 kilojoules. So I'm almost done. I also need to find, though, my moles. And I know we started off with 6.50 grams of sodium hydroxide. So I know the mass of sodium hydroxide, but I don't know how many moles. We could easily find it. So let me shrink this part down. Okay, so now we knew we had 6.50 grams of sodium hydroxide. I need to convert that to moles of sodium hydroxide. And I know that the molecular mass would be, what, 23, 1, 16, 40. Should be 40.0 grams of NaOH. So if I end up taking my 6.5 and divide it by 40, 0.5 divided by 40, that's going to give us 0.1625 moles of sodium hydroxide. Okay, so I have my moles. We knew also up here that we had 7.21 kilojoules, so I need my delta H to be in kilojoules per mole. Here's my kilojoules, here's my moles, so I'm going to end up taking, for delta H in kilojoules per mole, 7.21 kilojoules divided by 0.1625 moles. And when we do that, we should get 7.21 divided by 0.1625. We should get 44.4 kilojoules per mole. But I need to think about the sign for this delta H. Is it going to be negative or is it going to be positive? Because I want to know, calculate the delta H for the solution process. So I know that my temperature was rising in this case. So because the water is gaining in temperature, so it's increasing in temperature, that means the water's gaining energy, the system's losing energy, so my system must be losing this energy, which would be an exothermic process, and for an exothermic process, delta H is negative. So this should be a negative 44.4 kilojoules per mole. Okay, so this type of problem is what I'm going to ask you on your FRQ or on your multiple choice. So this is what we need to be able to know really well, that coffee cup calorimeter. So on your lab, you did a lot of this stuff, I think, combined with a lot of different compounds. And I think that we were thinking about things in terms of like, we did Q-Cal and we did Q solution and all of those things. But we aren't going to have to go into, I think, that much of depth in terms of an FRQ or something like that. So this would really be the extent, I think, of what our AP will ask us. Our lab was just a little bit more advanced. I'm only going to do one of these for now. So if you have questions on this one, then please let me know. I'll post another one on your blog if you're like, hey, I need another one, just maybe one more. Or we can do another one tomorrow in class. But let me know if this helps, and hopefully we'll be really good to go with the coffee cup calorimeter, okay? Like I said, post on the blog if you have questions, and I will see you guys tomorrow. Bye! Happy Halloween!